Hello everyone, today let's solve the problem number 322, coin change, right? So what the question states here, we are given an array of coins. This one I'm speaking of. Let's come to the example. We have been given array coins, right? So which contains distinct coin denominations and an integer amount as well. This is the distinct this one coin denominations means we can just consider if you want to consider this one as the rupee, I can just consider this one 1 rupee, 2 rupee and 5 rupee, right? So this is basically of the distinct coin denominations and an integer amount. So we have been given an integer amount here. See here, amount equals 11 they have given, right? I'm considering the first example. So you can use an infinite number of each coin. We have asked we have been said that we can make use of the coins any number of times, unlimited number of times, means we can use an infinite number of each coin they have said. So what is our main goal here? The goal is to find the minimum number of coins that is required to make up the amount. So whatever the coin denominations we have given, by making use of it, each coin we can make use of any number of times. There is no limitation, right? By making use of these coins, we have to sum up to the amount. Basically means we have to find the minimum number of coins that is required to make up the amount. So with minimum number of coins, we have to sum up to the amount that they have given, that we need to find out. Basically we have to return -1 if it is not possible. If it is not possible to make up to the amount what they have given, then we have to return -1 in that case. So that's what they have given in the question. So let's come to the first example here. So here you can clearly see coins we have been given 1, 2, 5, and we can just go with here 2 plus 2. There are several different ways, right, to sum up to the 11. To sum up to 11, you can just go with 2 plus 2 plus 2 plus 2 plus 2. Here 5, 5 2s will be 10 and 1. This will be 11 as well. But we are making use of the coin 2 5 times and coin 1 here 1 time, right? 1 rupee coin 1 time and 2 rupee coin here 5 times. So this will sum up to the 11 basically, right? So here we can make use of 1 as well. 1 11 times here, right? 1 plus 1 plus 1 plus until 11 times. So this will also lead to 11 here in this case. So we have been asked this to find the minimum number of coins that is required to sum up the to make up the amount, right? In this case we can go with this one as well. 5 plus 5 10 and 1. We can make use of 1 2 as well as the 5, right? These are the distinct coins that we have been given in the first example. So this will be the minimum number of denominations, minimum number of coins basically required to make up the amount. So in this case it is 5 plus 5 plus 1, that will lead to 11. This is fine. So let's come to the first example, second example here. Coins we have been given 2 and amount we have been given 3 and output we have -1. So coins 2 we have been given, amount we have been given 3. So when amount is 3, if the coin is only 2, this will lead to only even number, right? So 2 4 6 8, we can consider n number of coins, but it will lead to only even number 2 4 5 6 8 10 12 etc. So this will never be 3. So this will never be 3, right? So in that case we have to return -1. Let's come to the third example here. Coins we have been given 1 and amount we have been given 0 in this case, right? So amount we have been given 0. In this case we can directly write 0 itself, right? In this case we can directly write 0 itself, right? So uh, I hope the examples that they have given is completely clear. Means they have given us wonderful examples, right? Just for the sake of understanding purpose. So I hope these examples are clear. I hope the question is completely clear as well, right? So what we need to do is completely clear as well. At first, let's discuss the approach, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. So here, first thing that we need to note down here is we will be going with the dynamic programming. So we'll be going with the bottom-up approach, right? So bottom-up dynamic programming. So just keep this in mind. We'll be going with the DP, bottom-up DP, right? So I have considered the same first example that they've given in the question so that it will be easier to understand the approach, right? So here we have 1 to 5. So we have to find the minimum number of coins that is required to make up to the make up the amount basically. Here in this case, minimum we already have discussed this one. 5 plus 5 plus 1, that will lead to 11 basically, right? So we have to return the output as 3 because we have to find the number of coins that is required, right? Not the number of combinations. So here in this case, we have to return 3. 5 plus 5 plus 1 means 5 coins here in this case, and 1 coin here in this case, right? So 5 coins and 1 coin in this case, right? So this will lead to 2 plus 1, nothing but 3 in this case, right? So this is fine. Let's move on with the step-by-step execution here. The first step is initialization part. So initially what we'll do, we'll initialize that dp of 0 to 0, means 0 coins can make up to the amount 0. So this is the base case, right? Just remember this one. This is the base case. 0 coins to make the amount 0, right? So we will initialize the dp of 0 to 0. So all other dp of I initialized to this one, max equals amount plus 1, nothing but 12 here in this case. Max equals amount plus 1, 12 in this case. Let's move on with the second edge case here, iterating coins. Here in this case, coin we have as 1. dp of 1 will lead to min of 12 comma dp of 0 plus 1. dp of 0 is 0. 0 plus 1 is 1 in this case. Minimum is dp of 12 comma 1 it will be 1 in this case. So we are just going with the 1, right? So we are just going with the 1 in this case. So now we have got dp of 1 as 1, right, from this. So dp of 2 is min of 12 comma dp of 1 means 1 plus 1. In this case 12 comma 2 it will be 2. Like that we'll do for all the 11, right? So until dp of 11, right? Until dp of 11. dp of 11 will be 11. dp of 1 will be 1. dp of 2 will be 2. For the min of this will be dp of 11 will be, it will be 12 comma 11, and we will be considering the minimum. 11 will be minimum, so dp of 11 will be 11. So we are using only ones here, right? We are considering coin only 1, right? So next let's go with the coin 2 here. When we are considering only coins 2 here, means either we can consider 1, 2 or 5, right? So dp of 2 will be min of 2 comma dp of 0 plus 1. Initially it will be 0. 0 plus 1 is 1. So 2 and 1 minimum of 2 and 1 will be 1. Same goes with this one, we get 2. Same goes with this one as well. For this will be 2. dp of 11 will be basically 6, right? dp of 11 will be basically 6 on this case, right? So I hope this is fine. So let's come to the third one, dp of when we make use of the coin 5. So when coin is 5, so dp of 5, 6, 10 and 11. So here you can just check from dp of 1 to dp of 11. In this case we have coin 5, right? 5 we have to check with 5, 6, 10 and 11, right? So here 5, this one min of 3 comma dp of 0 plus 1, this is 1 again. So as it is for dp of 5 this is 1. dp of 6 will be, in this case 1 plus 1 will be 2, and 3 comma 2, min of 3 comma 2 it will be 2 itself. Min of 3 comma dp of 5 will be 1. 1 plus 1 again 2, this will be 2, and this case it will be 3 as well. So here dp of 11 equals min of 6 comma dp of 6 plus 1. In this case dp of 6 is nothing but 2. 2 plus 1 will be 3. 6 comma 3 it will be 3 itself, right? So this is fine. We got 1, 2, 2, 3. So in this case this one we will return, this one we got here as 3 basically, right? This one will return as output basically. This will be our output. So just keep this in mind. Just keep this in mind. So this one, the last one, what we got here is 3, and this one will return this one as output. So this is bottom up tabulation basically, right? So this is the bottom up tabulation. So finally we got dp of 11 equals 3, right? So this we will be returning as output for the last one. So this will be the basic calculations we'll be doing basically behind the scenes. You can call this one as behind the scenes basically. So so rather than calling this one as behind the scenes, this is how the calculations are made, right, for this one. So now we are completely familiar with the approach. So the output that we got here is 3, which is equivalent to the output that they have given for the example 1 in the question is also 3. So the approach works absolutely correct on this case, right? So now we are completely familiar with the approach. As we are completely familiar with the approach, let's discuss the edge cases step by step, right? So I'll just come here, and this case 0 amount. So let's go with the first edge case here, 0 amount. Coins we have is 1, amount we have is 0, and the output we have is 0 as well. So coins we have is 1 and amount we have is 0, and the output will quite obviously 0 because amount they have given here 0. So 0 ways are there. So we have already discussed this one. For the amount 0, we have 0 ways to find the number of coins. So 0 number of coins will be required to make up the amount 0. So that's what we have discussed earlier. Just keep this in mind. So let's go with the second edge case here. Impossible to form the amount. We have been given amount 3, but coin we have 2. So coins, this will, when we sum up, it will lead to even number, right? It will never lead to this one, odd number 3. It will never lead to the amount 3. So in this case, output that we need to return is -1, right? So this is fine. Let's move on with the third edge case here. Single coin type, nothing but exact multiple. When I say exact multiple, coins 1, amount has been given 2 here in this case, right? So there are, we can just go with 1 plus 1, right? So 1 plus 1 in this case, 2. So output will be 2. We need to return 2, right? So let's move on with the fourth edge case here. No valid combination here. So we have 5, 3, and the amount that we have been given us 2, right? If we start with 5, we'll go with 5 itself. If we start with 3 also, then also it will not lead to the amount that they have given. So this should be, amount should be always greater than at least 1 coin, greater than or equal to at least 1 coin that they have mentioned in the coins array, right? So I hope this is clear. In that case, in this case, we have to return -1, right? These are the 4 edge cases that we need to keep in mind. The first edge case is for the 0 amount, the second edge case is for the impossible to form amount, and the third edge case is for the single coin type exact multiple, and the fourth edge case is for the no valid combination. These are the 4 edge cases that we need to consider here, right? So now we are completely familiar with the edge cases as well as the, what do we call, approach. As we are completely familiar with the approach as well as the edge cases, we are good to write the code. Let's start writing the code now. We know that iterated value of the DP is nothing but the minimum coins to make amount I, right? So I can just write in this way. So int, so this one DP, let me assign this one to the new. So we are just creating the DP array here. So new int of size amount, whatever the amount we have of size amount plus 1, right? So iterated value of the DP is minimum coins to make the amount I. So the next step here is we will be going with the, we need the, this one, just give me a second here. So in this case, max is unreachable value, means more than the amount. So we are going with the amount plus 1, right? So I'll just initialize max to amount plus 1, not initialize, basically assign, right? So the next step here is, let's go with the iteration. Let's go with the traversal or the iteration. Here in this case, we are filling all the iterated value of the DP with max. In this case, I'll just go with for int I equals 0. Let me go with I equals 1 here. I less than or equal to amount. So let me go with I plus plus. So within the for loop, first thing, let's assign this one to the max, right? So the next step is base case, means 0 coins will make amount 0. We have discussed this one several times in the approach. Let me give here DP of 0 equals 0. This is fine. The next step is here, for each coin we have to try to form all the amounts that is greater than or equal to individual C. Means first let me write here, first let me write the for loop here so that you will understand this one better. So we are considering each coin of coins, right? Each coin denomination we are considering of different coins. So inside this, let's go with one more for loop here. So this is for the means we have to try to form all the amounts that is greater than or equal to C, right? So in this case, I'll just give and I, let me give I equals C, I less than or equal to amount, and let me this one increment the I. This is fine. So within the for loop, we have to use the current coin. right? So this will be iterated value of the dp equals math.min of dp of I, comma dp of I minus c, this one plus 1. Hope this is clear. So the final step here is we have to return the dp amount. Means we have to check if it is reachable. Means whatever the coin combinations that we are making use of, whether it makes the amount or not. That's what we have to check, if it is reachable, right? So in this case, just give me a second. Somewhere I have done wrong here. What I have done wrong, I don't know. So let me do one thing. Let me remove this flower bracket. Basically, this is not required. I should have closed the flower bracket here itself. It's fine. So no need of this bracket. So let me format the code once, and final step here, let's check whether it is reachable or not. So here in this case, we will return dp of amount, this one equals max. If it is not, then we have to return -1, and if it is, then it will be dp of amount. So this is fine. So let me format the code once and let me hit the run button. So we have error here. What is the error? Line number 13. So here, yeah, this has to be just comma. So let me hit the run button again. So yeah, now the sample test cases are getting passed. So let me hit the submit button. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is bottom-up DP or bottom-up dynamic programming, right? The tabulation I'm speaking of, bottom-up tabulation. So whatever we discussed, iteration, initialization, iteration, that's the calculation part, right? Nothing but bottom-up tabulation we saw. So here, the time complexity. Let's speak about the time complexity here. What would be the overall time complexity? The overall time complexity would be because of n into m, right? So we know that n is nothing but the number of points and m is nothing but the amount. So what would be the space complexity here? The overall space complexity would be because of m. So overall time complexity would be because of n into m, and the space complexity would be because of m, right? For the code that we have written. I hope the complexities are completely clear. I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.